So we saw 3 different ways of proving things. One was the direct way, in which you assume all of the premises to be true, and then you move on from there. At the end, you want your conclusion to be proved true. Okay, that's the direct way. The indirect way says that you do apply modest tolerance to what you want to prove. So you assume the negation of the conclusion, and you prove the negation of your premises. Okay, that's indirect. The proof by contradiction or by way of contradiction is that you assume the negation of your conclusion, and you also assume your original premises, not their negation. Okay, this is what you start with. If you think you don't need the assumption which says that negation of conclusion is true, then you are actually doing indirect proof. Okay, by way of contradiction means that you need to kind of assume the negation of the conclusion. Okay, so that's by way of contradiction. You assume the premises, original premises, not their negation, and you assume the negation of the conclusion. Okay, and what do you finally prove? What? What's the final thing that you prove? Kind of negation of your assumption, but the particular statement that you're looking for is a contradiction. Okay, that's what you're looking for. You're looking for a contradiction. Okay, once you reach a contradiction, it means that what you assumed was wrong. Okay, since you assume the negation of your conclusion must be true. Okay, good. So I wanted to start today with a proof of a statement that's actually wrong, and I wanted you guys to find it out. Is this on the slides जो अभी share हुई हुई है? Is it? It's not? Okay, then this is a good exercise to find out what's wrong with this proof. Find it out. Raise hands if you know what's wrong with this proof. जोर से बोलो. Sixth says Q of C, and it says that I am simplifying 5. Oh, that's wrong. That's wrong. Instead of 5, you want 4 here. Okay, that's one kind of typo here. But there's something more wrong with this proof. So you're right. On this line, I need to have simplification of 4 instead of 5. Okay, that's one thing that's wrong. What's something more that's wrong? Okay. Okay, जोर से बोलो और probably rephrase करो.
3 और 4 में जो B, C और Q, C के पीछे and है
वो क्यों है? Okay, so this is existential instantiation actually. So you say that C is, you can actually just not have an and here and it would still be a fine statement, which is that C is a particular element for which P of C is true. So this is one way to write it down, saying for which वाला जो part है ना वो लिखे बगैर अगर if you want to say it, C is a particular element and P of C. Okay, so this is valid. This is fine. It's just kind of a different language than what we learned yesterday. Yes. You have a guess? Yeah. Third or fourth में conjunction. Sure. Okay. So you can write this statement without conjunction. Okay. But what I'm saying is this is not kind of a big problem. It's fine. The statement is fine. Okay. So what you're saying is that for a particular element C, P of C. That's how you want to write it, right? I'm fine with it. That's probably the better way to write it down. Counting the 8 missing. Awesome, good. There's a lot of things wrong with this statement. I should. All right. Anything else? Everyone finds it perfectly fine, apart from the 10 problems you just figured out. Okay. The thing that's wrong is line number 7. You cannot do 7. And I want someone to figure out why we cannot do 7. What's wrong with 7?
So because we have not done, if we do the extension in derivation, we have to.
Whoa, no, I want you to say the word. Go ahead.
We do the extension, we also have to change not for all x to c.
Yeah. So what's the problem? Yeah, you kind of figured it out. So the thing is, C stands for a particular element in the domain, okay, for which P is true, okay. That's fine. On line 4, we are also saying that C is some particular element of the domain for which Q of C is true, okay. But here's a problem. If I take C in both of these statements, what I'm trying to imply is that the first C is same as the second C. Okay? So think of this as that yeah, that's what I'm trying to say. Thank you for putting it in words. Okay? Let me give you an example. Another example. When I say that someone in this class scores A in discrete, okay? And then I kind of use a variable for that person who scores A in discrete, okay? And then I make another statement which says there exists a person who scores A in data structures, okay? And then I use the same variable for that instantiation. Then I'm kind of implying that same person scores A in both of these subjects, which is not the original statement. Original statement only says that there is one person who scores A in discrete, and there exists some person who scores A in OOP or data structure or programming fundamentals or functional English, okay? So the problem is I should not use the same variable when I am transferring there exists Wally statement into C Wally statement, when I'm picking a particular element. Okay, I should not pick the same variable, because that gives me 7, which is not true. 7 is saying that P of C and Q of C is true for the same C variable. Okay, so essentially what I'm saying is that 3 and 4 के अंदर जो C use हुआ है, that's different. It's not the same C. Okay, which means that I cannot do 7. So what I should do is use some C here and probably some D here, or some C1 here and some C2 here. Okay? और जब मैं ऐसे करूँगा तो फिर 7 मैं नहीं कर सकूँगा conclude. Okay? And my proof will fall apart. Is this crystal clear to everyone? This problem? Yes. Absolutely हो सकता है. So देखो उसके इक्वल होने के लिए मुझे कोई कंडीशन रखने की ज़रूरत नहीं है. अगर मैं ये कहना चाहता हूँ कि वो इक्वल नहीं हो सकते, फिर मुझे कुछ रखना पड़ेगा. Okay, so let me make two statements. I'm saying that there is someone in this class who scores A in discrete. उसके फ़ौरन बाद I'm making a statement there exists someone in this class who scores A in OOP. Okay, I don't need to say that it could be the same person. These two statements already imply that it's possible that it's the same person. But if I want to say that it cannot be the same person, then I must say that they cannot be the same person. Okay? So when I'm making these two statements, they already encompass the possibility that they could be the same person. Okay? But they don't imply it. They don't imply that it's always true. Okay? This statement 7 is implying that it's always true. It's always the same person for which P is true and for which Q is true. Are we good? You want to say something? Questions? Okay, cool. So this slide was kind of to give you a wake-up call that at times when you are doing instantiation or generalization, you need to pay very careful attention. Okay? All right. Especially when you are doing existential instantiation. Okay? If you are doing existential instantiation on the same domain, okay, use different variables. That's kind of fine. That won't solve all of your confusions or problems, but this is one way to solve this particular problem. Okay, if your statement is about the same domain, for example, you have two statements, they have something to say about the domain of integers, use different variables to existentially instantiate them. Are we good? Cool, moving on. Actually, there was something on the statement as well. So, universal generalization, maybe you need to be careful. Okay, existential instantiation is the hard part. Jahan pe you need to be very careful. Existential generalization is quite easy usually. Okay, universal generalization is hard. Universal instantiation is usually easy. Okay, when you are doing the universal instantiation, you can pick anyone. Okay, if you have two statements which are universally quantified about the same statement, you can pick the same guy. Because the statement is true for everyone, okay? You can pick the same guy for which both of these statements are true, right? But when you're doing generalization, that's going to be hard.